Good evening. My name is Cyrus Ndirangu. I am a solutions architect, a Microsoft Launchpad ambassador, among many others. I am finalizing my computer science degree. And today we are going to be talking about big data processing with NoSQL databases. And I'd like to thank Zindi Afrika for this opportunity. So without much further ado, we can proceed. Today's session is going to include an understanding of big data as a term. Like, what is it what do you understand by the term big data? So big data is a term used to describe large and complex data sets that cannot be easily managed or processed using traditional methods. Such methods include sampling, which involves obtaining a small set of data from a large sample data set. So big data is like, tuseme nini, how can I use Kiswahili to make it more chewable? It's a really big data set. So like it's a bit difficult to work with it. Say like the way we used to working with say like opinion counts in surveys, where they just take a sample, small number of people, and then they use that as the opinion of the general majority. This would be a bit impossible to understand trends of data. So big data is prevalent in various industries, including social media, e-commerce sites, healthcare, and finance services. MongoDB is a leading NoSQL database that offers a flexible and scalable solution for managing data, big data. And I will use MongoDB to kind of create an integration and see how you can use MongoDB to work with your big data use cases. So what are some of these big data use cases? So some of them include social media analytics. Social media analytics includes analyzing large volumes of social media data to gain insights into customer sentiments, trends, and user behavior. Working with MongoDB, it's very easy to customize your user model, your comments model, your reviews model, to try and understand the sentiments that are going through all your users' comments on a specified post. It is very easy to do things like predictive maintenance. So for example, if you're processing sensor data from machinery to detect patterns and predict maintenance requirements, thus reducing downtime in your organization. Say for example, a company like EABL, East Africa Breweries Limited, where they have sensors that emit data frequently. So you can use that data to analyze and see when your machinery is like approaching service, there is a trend that occurs within your machinery. It is easier for you to understand this with sensor data. It is easier for you to understand the trends of your machinery by using a storage. If you have like large dumps of data, it is easy for you to use that data to try and make sense of trends and to try and see and predict future maintenance patterns for your machinery. Fraud detection. It's easy for you to analyze vast amounts of transactional data to identify fraudulent patterns and prevent financial losses. In financial industries, fraud detection is among the key pain points of what they try to cover every single day. And with MongoDB and with the help of big data, you're easily able to see and understand scenarios that pop up, and you're able to predict, like the next one. If such kind of a case happens again, you're able to stop it before the victim like tries to move away. Let's move on. So we've talked about MongoDB a lot. So what is MongoDB? So MongoDB is a document-oriented NoSQL. NoSQL means no structured query language database that provides a flexible schema for allowing easy handling of unstructured and semi-structured data. So for example, where I was working before as a junior developer, we had a task of reviewing database records that had malformed data. This was production data that had phone numbers that were numbers, others were strings. We had people who were storing goods at the database. We had malformed data, where you want numbers, they are strings, where you want strings, they are numbers, where you want objects, there are arrays. So, there was that relation that wasn't created there. And it was so easy for us through easy scripting and through aggregations, we were able to convert the data from one structure in production. We cloned the database cluster, and then we were able to use the clones to now replicate the database, and then we were able to normalize the data within, I think it was within 4 hours. Yeah, production data that had around 80 GB. So unlike traditional relational databases, MongoDB uses a JSON-like document model called BSON, Binary Structured Object Notation. So this enables seamless integration with modern programming languages and frameworks. So when you look at the structure of BSON document, a MongoDB document, it sort of looks like JSON. Actually, you wouldn't notice, apart from noticing now things like types like MongoDB user ID types, not user ID, object ID types. You will be able to see that is like a weird JSON format, but everything else looks like follows the JSON structure. MongoDB offers horizontal scalability and automatic sharding. This means that you can enable efficient storage and processing of large volumes of data. Whenever you need space, you're able to scale. Whenever you need different shards to work on, you're able to easily integrate all those large volumes of data and easily and flexibly work with them. Its flexibility and numerous indexing options, coupled by powerful query capabilities, make it well suited for handling complex data processing tasks. We'll talk more about sharding in the next chapter. I have a dedicated section where we'll talk about sharding and how it's related in big data. So how is MongoDB better suited for big data? So one, we have a flexible document model. So MongoDB's flexible document model allows for easy handling of unstructured and semi-structured data, which is common in big data scenarios. You find an organization that has large amounts of CSV data files, dumps, Excel file dumps, and they need to try and make sense of this data. So you can write a script that creates a sort of model, a schema, and you're able to map the schema using ODMs to MongoDB, and you're able to create a readable structure from the numerous data sets that you have. Horizontal scalability, we talked about this. MongoDB's ability to distribute data across multiple servers enables efficient storage and processing of large volumes of data, allowing for scalability as data grows. So for example, if you have decided to use 70% capacity of your storage server, you can create another server that will handle the extra load, and together they will be able to form clusters and work together. This will enable your applications to have high availability, because now you have the possibility of your application having multiple data servers, now integrating and like integrating seamlessly with your application in clusters. So it's easy for you to scale up, and when data you disperse data or you do away with data, it's easier for you to scale down to one server depending on your needs. And you're also able to distribute load among the different servers or clusters. MongoDB has powerful querying capabilities. So MongoDB offers advanced querying features like the aggregation pipeline and the MapReduce framework, which enable complex data processing and analytic tasks on big data sets. So MongoDB has something called the aggregation framework, and this aggregation pipeline enables you to have numerous chains or numerous operations on data numerous transformations even on data, where if you would want to get trends in data, it is easier through simple scripting on the aggregation pipeline, which is easily accessible through graphical user interface through MongoDB Compass, and you're able to create like an understanding of the data that you have, and you're able to even export the data that you get. Integration with modern technologies. So MongoDB is well known to integrate with modern programming languages and frameworks, which makes it easier to develop and integrate big data applications. So it's easy for you to integrate your applications, whether they are C# applications, Java, Python, JavaScript. MongoDB is a plugin for ensuring that you're able to integrate your data with everything, every known framework out there, at least the popular ones. So we have automatic sharding. So this is actually one of the reasons why I love MongoDB. So MongoDB's sharding feature distributes data across shards, ensuring workload distribution and high availability in big data environments. So let's just proceed a bit. What is sharding? So sharding in MongoDB is a data distribution technique that enables horizontal scaling across multiple servers or machines. It allows MongoDB to store and process large amounts of data by distributing it across a cluster of servers. So what does this mean? So you have your server, and it was approaching around 60%, and not around 60%, around 80% of the load. And it has become a bit, it is taking some time a bit to, to process data. So with MongoDB automatic sharding, after creating different clusters for your data servers, MongoDB will automatically distribute data among your clusters, among your shards, and ensure that all your servers are working seamlessly to create the same, to achieve the same goal. So it happens behind the scenes. So it's easy for you to abstract, because this is something that MongoDB does for you behind the scenes. So sharding is primarily used to address two key challenges. One, data volume. As data grows beyond the capacity of a single server, sharding allows the data to be divided and distributed across multiple machines, servers, or shards. Each shard contains a subset of the data, allowing for efficient storage and query processing. 2. Workload distribution. So Shardly evenly distributes the read and write workloads across multiple servers, ensuring better for performance and scalability. This allows MongoDB to handle high traffic and large data volume by parallelizing operations across multiple shards. So you can see why MongoDB is best suited for handling big data. One, because this is what sharding addresses, and two, this happens automatically behind the scenes. I think I've worked with a couple of databases where you really have to do, or it's really a pain for you to have to understand if you have like a Docker container for like a PostgreSQL, that's a pain. And we'll also talk about the managed instances of MongoDB, where you just need to work on your data, they'll manage the servers for you. But that's a story for another day. So data processing in MongoDB. So if you are working with big data, then you will need to use that data to do some sort of processing to get some form of analytics. So if you will be using big data, by preference, if you will be using MongoDB, it is assumed that you will be using MongoDB for data processing and analytics. So MongoDB's document-oriented nature and flexible schema make it suitable for handling diverse and unstructured data. MongoDB provides powerful querying capabilities, and aggregation features for data processing and analytics tasks. Its scalability and performance allow for processing large volumes of data efficiently. Such scenarios include e-commerce site, healthcare apps, financial systems with loads of relationships. So for example, the system we were working on, it was a platform for connecting farmers with banks and warehouses, such that when a farmer has goods in a warehouse, they can use the warehouse goods as collateral, and through our local database we can map the value of goods the minute the farmer decides to take up a loan. So the goods are valued and the data is keyed into the database. So we have quite a number of relationships between users, and all that data is chained with a blockchain. So whenever a user makes a deposit in the warehouse, a blockchain ID is created and a blockchain instance is added where we have the goods of the farmer and all that stuff. The blockchain ID is stored in the MongoDB schema, and when we want to access, say, a specified blockchain ID and see, because like on the blockchain you can only write, you can only write and read. You cannot edit. So yeah, when we want to access a certain ID to validate whether this is really the goods that were added, we can be able to see that yes, the farmer had deposited 100 kgs worth of maize that was evaluated at this much at that time. So through that data, banks can then evaluate the goods that a farmer has through his credit, and then they can also now send money directly to his phone number, and they can then send a message to the blockchain through our system, to the warehouse through our system, and tell the warehouse admins to lock goods for, say, Cyrus, so that they can be used for collateral. So as you pay the loan, your specified amount of goods are released from the blockchain. This tool was being used around by 5 million farmers in India, and it was a really perfect use case of seeing how MongoDB can tackle different relationships. So for example, a user, a farmer, and his goods in the warehouse, and a farmer with the blockchain ID, a farmer and his goods are related to the price model, how much were they valued, how much is the market valuing them at this time, the values that keep changing based on market pricing. And now there was so much data that was coming in and out of the application. So we've talked about the aggregation pipeline, and it was something that I use very often. Any day when I'm working on MongoDB, you definitely need to work on the aggregation pipeline to make data make sense. So the aggregation pipeline is a data processing framework in MongoDB that allows for the transformation and manipulation of documents in a collection. So per se, let's say you want to understand how many people have borrowed a loan from banks in, say, Pune region, per se, let me use that scenario. And through that, you can be able to narrow down and see the people who've taken a loan from Bank A are 30, the people who've taken a loan from Bank B are 30. And through the aggregation pipeline, you can add another filter for filtering and checking whether all people who have taken the loans have cleared the loans, and you can export the file to a CSV file. So the aggregation pipeline is a way for enabling you to do multiple transformations and see results as they unfold. It provides a flexible and efficient way to perform multi-stage data processing and analytics operations. In the aggregation pipeline, data flows through a series of stages, with each stage performing a specific operation on the documents. Now, this is not quite a technical presentation that, but yeah, I do have some sort of snippets at the front, and we'll be able to see what I sort of mean by multi-stage data operations. The output of one stage serves as the input for the next stage, allowing seamless, coherent data processing flow. So for example, you need to understand the MongoDB structure properly. You need to understand how to work with indexes. If you're working with big data, I assume you're a guru in data. So if you understand how indexes work, you can index your unstructured data properly. After indexing your data properly, then you can move to the aggregation pipeline, where now you can perform multi-stage operations on your data while leveraging the indexes in your application to make sure your operations are fast. This pipeline approach enables complex data transformations and aggregations to be performed in a structured and an efficient manner. So far, by the way, I hope if there's no question, I'll gladly continue, but I'd be happy. Oh yeah, there's the link to the slides. Yeah. Yeah, okay. So we've talked about the aggregation pipeline. So how would you use the aggregation pipeline for data processing? What would it look like? You know, like what is the required, you know, stage of how should it look like, you know, per se? So um, based on my couple of interactions with, you know, the aggregation pipeline, I've been able to see um, this is not like the definitive way of how your data should be following, but I've been able to see these three stages are the most common in any and every scenario of you doing some data manipulation. So anything with a dollar sign is a pipeline operator, and it has a special key or a special function value. When MongoDB sees $match, it knows it's supposed to match. So for example, when you use the aggregation pipeline for data processing, some things you might need to do are filtering and projection. So the $match stage filters documents based on a specified criteria, allowing for data selection and extraction. So when you pass the match stage, while filtering documents based on a specified criteria, I think you can be able to see that indexes really help a lot when, you know, it's moving through all the documents in your database. So having indexes will help it work a lot faster. The project stage selects specific fields from documents, enabling data shaping and reducing output size. So project is for transformation. So it picks specified fields, and it transforms the data. So it reduces it to slightly what the value that you are required to see it. I think once I'm able to do like a practical demonstration, you'll be able to understand what it is I mean by selecting specified fields and enabling data shaping. So for example, if you've been told to find the number of people who have taken a loan from said bank, you're able now to project the user loan field and the bank field, and you're able only to return the field of the value of the name and the number of the people who have taken a loan from the said bank, and even the amount of loans that have been taken from that period. So a project stage is like a transformation. It enables data shaping and sort of reducing the output side. So if you want to group data and you want to create aggregations, the group stage allows grouping of documents together based on a key field. So you can see here you also need indexes. So based on a key field, enabling aggregation and summarization of data. So some aggregation functions like sum, average, max, mean, etc. can be used to calculate metrics on grouped data. So you can see now when you're grouping data, you would require some form of indexing so you can group data. It only helps to work with your data faster. So as in the aggregation pipeline, there are some operators that require indexes to work efficiently, and some don't require indexes to work efficiently because they'll just be taking the lump sum of data. So like you can see here, the group index, it uses a key field. Although it's taking the lump sum, it will definitely require an index because it will have to take key fields from all specified data sets. So we have sorting and limiting. So the sort orders documents based on a specified field, facilitating data organization and analysis. The limit stage restricts the number of documents passed to the next stage, aiding in result control. So you can see limit doesn't necessarily mean, doesn't necessarily use indexes. So in the aggregation pipeline, it can come the last one in the operator. So this makes it a bit easy for you when you're working with multi-stage operations on data. You're able to understand what needs indexes and what doesn't need indexes. And all these values have been, all these documentations have been given in the MongoDB documentation. You're able to read so much of this stuff. I was able to get most of my stuff from the MongoDB documentation. By the way, super thanks to those guys. They're working on really nice documentation. So if you want to do a join and a lookup, so a lookup stage performs the left outer join operation to fetch related data from other collections. So if you have like a student related to a model, you can do like a reverse from the class to see how many students belong. It's called a lookup, and it can be able to see do a left outer join. I think if you're from SQL, you understand really what a left outer join operation means, and fetch related data from other tables, or here now in MongoDB collections. It allows combining data from multiple collections into a single result set. And it's quite intuitive, and it's so easy to set up. Transformations and expressions. So MongoDB provides a range of transformation operators like add field. So for example, if you want to add new fields, for example, you're doing a project and you want to add a new field to describe the new value that you're adding, you can do an add field operator, the project, the expression, etc. to modify and manipulate data within the pipeline. Expressions enable complex computations and comparisons within the pipeline stages. You can even feed, what are they called? Regex expressions. And you can, or if you understand the regex expression well enough and you know it won't come to bite you, it's really, you can even use regex expressions in your queries, in MongoDB. I've used them when I'm using search. So what are some of the real world use cases where MongoDB is used? So one is real-time analytics. So MongoDB is used in applications that require real-time analytics, such as monitoring and tracking systems. It allows for the collection, storage, and analysis of large volumes of data in real time, enabling organizations to make immediate data-driven decisions. So for example, if you have an Uber application, I can see MongoDB being a wonderful use case because it will always get feedback from the driver every seconds or so, tracking the location and reporting the location back to the server, and the server can then fetch the location and present to the user. And then you can see now the small car moving. I can see how MongoDB would be better suited for a role like that. In Internet of Things, data processing. So MongoDB can be used to manage and process the high velocity and variety of data generated by IoT devices. If you are aware, IoT devices generate a lot of data from sensors, and MongoDB enables the storage and analysis of sensor data, machine-to-machine communication, and operational analytics, facilitating insights for smart city systems, industrial monitoring, and predictive maintenance. I was actually talking to students at University of Nairobi, and I was telling them how they can engineer smart city solutions and how we can use smart city solutions to modernize what is currently there in Kenya, like the expressway payment system, like security systems. Hapo Back Street, the government can just put some monitoring like the way they do in China. And we can just feed our model through data that is continually fed to MongoDB, and we can be able to see when people behave like pickpocketers, what they do, and we'll be able to detect them and send such kind of data to our police or squads on the ground. And we can be able to mitigate a lot of crime. We talked about so many use cases where we can use IoT for solving real world problems with unstructured or semi-structured data. 3, social media analytics. MongoDB is utilized in social media analytics platforms to handle massive amounts of data from various social media channels. It allows for the extraction, storage, and analysis of user-generated content, sentiment analysis, trend identification, and providing valuable insights for marketing and brand management. It is easy for you to do a search, a lookup, and see how certain topics, when people raise them, what sentiments they have, what kind of sentiment do they have, that kind of data is really craved by market people, because they know if you're feeling this kind of way, then we can feed this type of information your way, to make you feel nice. I think that's the kind of information the media use. Once they know like what's going on in politics, they are able to use that kind of data to sway you either in the positive or in the negative direction, because now they have the manipulation of data. When you're doing some social media analytics, like when Elon Musk took over Twitter, he didn't take over Twitter for, I think he's a smart guy anyway. I am not 100% sold in everything he does, but I know one thing, he made a huge move in acquiring Twitter, because I think there's so much freedom on Twitter. You can share a lot. You can be able to communicate freely. And it feels like you're, in touch with the world and not like some fabricated, what's it called, world that AI has put for you. Like, yes, there is some AI, well, all of them really. There is some AI fabrication, but I feel with Twitter, it's a bit more realistic. And, it's a bit more, it's easy. And why he's able to use that kind of information to do some analysis on us. I recently heard Reddit was going to shut down their API, and Reddit is actually such an interesting social media site because now they want to train AI on user-generated content. So the user content that people generate on their Reddit channels, people are now making their channels private so that Reddit cannot be able to access the data. So it's becoming it's people with their data on platforms that do not belong to them, but the data is theirs and they do not want models to be trained on their data. So yeah, social media analytics is a very perfect case where you can be able to create multiple relationships between people. You're able to do reverse joins, you're able to do reverse lookups, to do reverse analysis and see this person, what kind of, when we expose them to such kind of topics, these are their sentiments, which means you can push these kinds of insights, these kinds of data, these kinds of marketing stuff and things like that. Health data management. MongoDB is employed in healthcare systems to handle the storage and analysis of patient records, medical imaging data, and genomic information. It enables the secure and scalable management of diverse healthcare data, facilitating research, personalized medicine, and population of health analytics. So in health data, we've worked with MongoDB before, and we've been able to see when we were doing a project for a hackathon in Health Hack Australia, where we were sending the model. We had the model points, I think, and also we were sending the model results. So when you pass an MRI image, the result was being passed to the image ID, and we could use that kind of information and that picture that you now uploaded. We took a picture and then we had an upload like a backup online, and we would use that kind of data to do some analysis and further train data to be able to see what kind of you had an option of adding how you feel. And we would use now that data to now do some further analysis on, I think it was the MRI scans, and we were able to make some. We never won the hackathon, but we were able to make some pretty decent steps in understanding how the MRI images. I can't remember specifically what was going on because my job was integrating the output from the model with the backend database and the Node.js API, and then feed the data to the database and then return the data back to the user. So we've talked about a couple of things. We've talked about the aggregation pipeline. We've talked about how we can use the pipeline to do multi-stage operations. Now we're talking about what are some of the best practices that you can do in designing your database. So for example, when you want to migrate big data to your MongoDB application, what are some of the best practices you can use? Frankly, this doesn't tie down to only NoSQL or MongoDB. These are just some best practices I've found when dealing with data. One is data modeling. Design your data model based on the specific use case and query patterns. Normalize or denormalize data depending on the access patterns and relationships between entities. One common misconception is you do not need to normalize and denormalize tables or collections because you're using MongoDB. While SQL is a bit strict on these things, when you use MongoDB, you'll see how easy it is for you to mess yourself up because it's easy for you to work with unstructured data. But if you're able to understand how you structure your data, you understand what it is you need from your data query patterns, It's so easy for you to create models that are based specifically on the data that you want to present. Utilize embedded documents or arrays to avoid costly joins and improve query performance. Consider the balance between read and write operations and optimize the schema accordingly. Indexing. Identify the frequently queried fields and create appropriate indexes. I think that's fairly understandable. Use compound indexes for queries that involve multiple fields. Yeah, you can, I think you understand, if you understand how to work with data, you can index several fields into like a compound index, and you can use those ones for queries. Be mindful of the index size and its impact on storage and performance. Regularly monitor and analyze query plans to ensure the effectiveness of your indexes. You might have indexes that slow your system down. Query optimization. Analyze and understand your query patterns and identify opportunities for optimization. Use the explain method to examine query plans and identify slow or inefficient queries in your query patterns. Optimize queries by appropriate projection, filtering, and sorting techniques. Utilize covered queries to retrieve data directly from indexes, minimizing disk input-output. I think these points are fairly straightforward. If you have any point, feel free to unmute and ask a question. Number 4, use of the aggregation pipeline. Leverage the power of the aggregation pipeline for complex data processing tasks. Don't leverage this stuff to your API. Leave the database to do the heavy lifting. Utilize the various stages and operators to filter, group, transform, and aggregate data efficiently. Take advantage of the pipeline's ability to handle large volumes of data in a distributed manner. So don't forget about that part. Take advantage of the pipeline's ability to handle large volumes of data in a distributed manner. And with that, I've come to the end of my presentation. Thank you so much, guys. My name has been Cyrus Ndirangu. This has been a presentation on big data processing with NoSQL databases. Thank you so much to Zindi Afrika for giving me this opportunity, and Esther and G here. I think if there's nothing else, I'll take questions if there are any.